Here is number 2 from our homework last night. John is hitting baseballs. He tosses the ball 5 feet high in front of him and then hits the ball. The ball leaves the bat with an initial velocity of 50 feet per second. So the first thing we want to do is come up with an equation for the path of that ball. So we'll use the vertical motion model that we've gotten before. So h of t will be equal to negative 16t squared plus, what's the initial velocity?
50.
So we have 50t, and what is the initial height on this one?
5 feet plus.
Plus 5. So that's the equation we've got to have. And if we can't come up with that, then it's going to be difficult to get any of this stuff. All right, part A. How high is the ball 3 seconds after it has been hit? So, like we talked about in number 1, we got 2 choices. We can plug 3 in for t. Or, let's go ahead and get this in the table in our multi-view. So, I'm going to clear out my last one, and in there I'm going to put negative 16. We have to use x squared plus 50 x plus 5. Enter, enter, enter. So I can see if I go on my table to an input of 3, the output is what?
11.
11. So 11 feet for part A. Again, we could have gotten that 11 by taking 3 and substituting it in for t in the equation here. All right, part B. How long does an outfielder have to react until the ball hits the ground? Well, I would first look at my table, and I see that between a time of 3 and 4, the height is positive at a time of 3, it's negative at a time of 4. So I can tell somewhere between 3 and 4 seconds the ball would hit the ground. So I can't tell exactly on the calculator. Yes? Oh, okay. Well, we'll work it out here. Good, good. But so hopefully you got something between 3 and 4?
Yes.
Okay, good.
Yes.
But you can tell that on your table. When at 3 the output is a positive height, at 4 the output is a negative. It's somewhere between 3 and 4 that the ball will reach the ground again. So what we need to do is set the height equal to 0. So we would have 0 equals negative 16t squared plus 50t plus 5. Now, I would always try factoring, but you can pretty quickly see that there's nothing that's going to go into 16, 50, and 5. So that leads us to the good old...
Diamond method.
No, that's for factoring.
Just kidding.
Quadratic formula.
Yeah.
Quadratic formula. So I'll work that out over here. X or t, I'm going to use x equals negative, what's our b value? 50 plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, and I'm going to let my handy multi-view work that out for me so that we can quickly change to the negative case as well. So go ahead and bring up a fraction, and we'll put in negative 50 plus the square root of 50 squared minus 4 times negative 16 times 5 over, let's go ahead and work that out, negative 32. Enter. So what do we get there? What's the first answer that comes up? It's actually a negative. What the heck is that all about? We get x equals a negative 0.0969 whatever. So what is that all about in this problem? Remember, he hit the ball when it was 5 feet off the ground. So here is a rough sketch of the path of the baseball. This answer is representing this time back here before 0, as if the ball continued its path backwards. All right, we need our other answer, so I'm just going to scroll up here and change that plus to a minus, not a negative, be careful, put a subtraction sign. So minus, hit enter, and what do we get? 3.2219, yeah. So 3.22 seconds. So that is how long an outfielder has to react until the ball hits the ground. 3.22 seconds. All right, part C. What is the maximum height of the baseball? Where will we find our maximum height? At the vertex. We might be able to find it at the table. I don't think so in this one because these numbers would have worked out nicely if we were going to get a nice vertex in the middle. So we need to know the vertex. How do we get the x-coordinate of the vertex? How?
B over 2.
Negative b over 2a. So x-coordinate of the vertex is negative b over 2a. In this case, we'll have negative b is 50 over 2 times negative 16. So negative and negative makes positive. What's 50 over 32? Go ahead and we'll take a decimal equivalent of that. What's 50 over 32? 1 point what? 1 point? 5625. So that's the x-coordinate of our vertex. That says at a time of 1.5625 seconds, the ball will be at its maximum height. How do we find that maximum height? We've got to plug 1.5625 into the formula. Now I want to show you a little trick here on the table. So go back to table. You have that function still entered in?
Oh, the handy dandy multiplier.
Yes?
Yes.
You need that function in your calculator. Hit enter. And see where it says start? The very first thing that's flashing, start. Yes? Put 1.5625 right there. 1.5625. Then we'll leave the step at 1. Enter, enter. Oh, and look at there. What does the output give us?
44.06.
44.0625. So we essentially just plugged 1.5625 into this equation. That's all we did. So the maximum height is 44.0625 feet. Okay. And now we want to know during what interval is the ball below 26 feet high? During what interval is the ball below 26 feet high? So let's think about that for a second. That's actually going to be 2 intervals because the ball starts at a height of 5 and then it goes up to a height of
44.
up here 44. So it's going to go up to 26, be above 26 for a while, come back down to 26. So we're actually looking for kind of little region here and here. So we're going to find these 2 values and we'll be able to tell from there. So what do we put in for the height this time? 26. All right, so we'll have, instead of 0, we're going to have 26 equals negative 16t squared plus 50t plus 5. Now that would be fantastic if that factored, but that's not going to work. We got to move the 26 over. Move the 26 over so that we get 0 equals negative 16t squared plus 50t minus 21. Again, I would love to factor it. It's not going to factor, so what do we need to go to? Quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so let's plug that back into the quadratic formula in the calculator. All right, so I'll bring up a fraction bar, and I have negative 50 plus the square root of 50 squared minus 4 times negative 16 times negative 21 all over negative 32. Okay, and what does the first answer give us? It's actually semi-nice. What is the first answer?
1/2.
What?
1/2.
1/2. That's correct. So the first answer is 1/2 or 0.5. I don't mind if you use a decimal there. And we'll go back up to our quadratic, scroll over, and change the addition to subtraction. Subtraction, make sure it's not a negative. Enter. And what do we get there?
21/8.
21/8. All right, I am going to turn these into... we'll leave that at a half a second. Let's turn this into a mixed number. I know we rarely do this. What is this? This is 3, 2, 62 and
5/8.
5/8. Maybe it will have more meaning if we turn it into a decimal. 0.5,
2.625.
2.625. I think we'll leave it that way. So that's these 2 points right here. Here. That's actually, so between there and there is when the ball is above 26 feet. So when is the ball below 26 feet? The ball is below 26 feet
0 to 0.5.
from 0
No.
to...
From 5.
0.5.
From 5.
No, but we're talking about what time intervals. At a time of 0 to a time of
0.5.
0.5.
To and then from a time of 2.625.
And what we usually do is use a capital U for union. Then when does it go back below?
2.625.
2.625. Now what would be the upper end of this region?
Infinity.
No.
Negative.
Well, true infinity, but we're going to talk about in the real world context of this problem, when did it hit the ground?
0.
3.225. Okay, there we go.